Hello and welcome, everyone. We're so glad to have you join us virtually for this build session on training and deploying ML models at scale using Azure Machine Learning. I'm Anita Lamahason, and I'll be the moderator for this session. We have a dedicated area for you to ask questions, and we request you take advantage of it and keep the session interactive. I'll bring up a bunch of questions for the presenter to address in the Q&A section towards the end of the session. Without taking any more time, let me invite Chris Lauren and Sabina Cartaccio to drive us through the session. Chris and Sabina, the floor is all yours.
Thanks. Hey everyone, I'm Chris Lauren. I'm from Bothell, Washington.
And my name is Sabina Cartaccio, and I'm from Bellevue, Washington, and super excited for the content we have today.
Excellent. So, a quick agenda. We're going to give you an overview of Azure Machine Learning and how to train and deploy machine learning models. We're going to focus on doing this in the context of a couple of demos. First, we're going to show you how to use natural language processing, a super popular BERT-based model, to fine-tune this model to classify and route Stack Overflow questions. Then we'll show you how to use automated machine learning to predict or forecast the volume of support staff you'll need to be able to answer these questions in a timely manner and deploy that model as well. And then we'll dive into the Q&A. Now make sure and submit your questions throughout the session so that we can get to them as soon as we're done with our demos. We've had the pleasure of working with a wide variety of companies across a number of industries to help people achieve a digital transformation, using machine learning to achieve their digital transformation across a wide variety of scenarios like predictive maintenance, fraud detection, inventory management, and many, many more. Across all these different scenarios, Azure Machine Learning provides a unique set of capabilities to help people of all skill levels use machine learning, including automated machine learning, where you can simply upload your data, specify which kind of thing you're trying to predict, what kind of task you're trying to perform, like classification or regression. It'll train a wide variety of models, pick the best one, and then you can easily deploy that with a single click. If you would like a little bit more control, you can use the visual designer to drag and drop different algorithms, adjust the hyperparameters, or even bring in your own code, and then simply deploy that as well. If you'd like even more control, we have hosted Jupyter notebooks in the cloud using our compute instances, where you can use any open source machine learning library, including PyTorch, TensorFlow, scikit-learn, and more, and write any arbitrarily complex Python code, or Azure Machine Learning even supports R, in the cloud as well. Once you've trained your machine learning model, we have an integrated MLOps solution, which enables taking the best of the DevOps concepts for your machine learning capabilities. So once you've trained your machine learning model, you can integrate with Azure DevOps to automate the packaging and deployment of your machine learning models to the cloud or the edge. Regardless of what type of scenario you're trying to use machine learning for, the process is always more or less the same. You always start by preparing your data and then training your machine learning model. And this takes some amount of guess and check, and we'll show you a couple of different solutions to help accelerate this process. But as you try and train the best machine learning model, once you get one, then you want to validate the results. You always want to test your code before you deploy it, right? And then you'll package the machine learning models into Docker containers using the built-in capabilities in Azure Machine Learning to deploy either to the cloud or the edge, and then continuously monitor how well those machine learning models are performing, and will enable automating the whole process end-to-end using our machine learning pipelines. So let's go ahead and dive in to see exactly how this works in a real-world scenario. Here we have the Machine Learning Studio. This is a web UI where we can keep track of our experiments, our machine learning models, and more, kind of everything that a data scientist needs to get productive right away. Here you can see we have an experiment, which is kind of the guess and check process, the scientific methodology behind data science. You can see that we're trying to achieve a scenario where we're going to classify Stack Overflow questions, and I've tried this multiple times. You can see here, this is a particular run of this experiment. You can see which compute cluster I ran this on, and even which input data set I used to train this machine learning model. Having that lineage tracked automatically back to the input data set is super helpful for other people in my team to understand what data was used to train the model. And it's also helpful for compliance or regulatory reasons, because sometimes you need to have proof as to what input data set you used. You can also see that we have the metrics that I logged during this experiment run to see how well the model is performing. And once I've trained the model, then I can deploy it. We can see here in the model registry different versions of the same model, the link back to the experiment run that was used to train that model, and I have the full lineage and traceability out to the different deployed services as well. So we can see the scoring URI, how much memory it's used, and more. Well, let's go ahead and go into the notebook section here, where we can see I can use Jupyter Notebooks built into the ML Studio UI directly. As I mentioned, we're going to classify and route Stack Overflow questions using the BERT-based DNN model. First, we'll connect to the Azure Machine Learning workspace. So you can think of that as everything that you can see here, the data sets, the pipelines, models, and more. But we can access that from the Python SDK directly in the Jupyter Notebook or in VS Code, PyCharm, or anywhere else you want to write Python code. We'll grab a handle to the input data set. In this case, it's the collection of Stack Overflow questions that we've labeled so that we can route them. If I don't want to use the built-in Jupyter capabilities in the UI here and prefer to use the native UI that you might use on your local machine as well, you can see I can quickly open Jupyter or Jupyter Lab as well. So I'll toggle over here and we'll see I can access all the same functionality in the native Jupyter experience. These are the individual labels for the Stack Overflow questions that we've created as the input training data set. And I'll grab the handle to the compute cluster. So I'm going to use this to submit this job to an automatically scaling AML compute cluster, which will spin up GPU VMs when I submit this job and then tear them down again when I'm done, so I can pay as little as possible to train this machine learning model. To lower my costs even further, I'll set this to low priority VMs, which means that it will use kind of spot pricing for VMs that are available to reduce my costs. To get started with training the model, first I'll create this experiment, and that's like a container for all the different attempts or iterations or what we call runs of this experiment. So I can compare different runs together to see which one's performing the best. You can see I can bring in any arbitrarily complex Python code to train my machine learning model. In this case, I'm using a combination of TensorFlow and Horovod to distribute this machine learning training job across the GPU cluster. I'll input my data set as well, and then I'll submit this job. And once I do, then I can see directly here in line with the Jupyter widget how well the machine learning model is performing and get access to all my logs as well. If I would like to monitor the job later, if I've walked away from my machine, for example, all the details are captured in the cloud, as I showed you earlier in the experiment details view as well. Or I can save this URL to share with other people on my team so they can monitor it. Oftentimes, training these types of machine learning models benefit a lot from tuning the hyperparameters, different input values like the learning rate, for example. But this process is, again, kind of a guess and check type of approach. I don't always know what are the best values to input. Azure Machine Learning has built-in automated hyperparameter sweep called Hyperdrive that enables automatically iterating over different combinations of these input values to train the best machine learning model. You specify which metric you want to optimize for and whether you want to maximize it or minimize it. And of course, I want the best accuracy possible in this particular case. When I submit this hyperparameter sweep, then we'll see, again, I can monitor how well it's performing. And notice it actually ran multiple jobs to try and train the best models with those different input values. And you can see one of them performed fairly poorly. As I mentioned, different input values are going to get different results. And in this case, the result was so poor compared to the others that it actually canceled early to avoid further compute costs that weren't going to accrue value to training a better quality model. Once we've got the best run, then we can go ahead and grab that and register the model directly in line here. And so this is like saving your build artifact, for example. This is going to enable you to find those machine learning models later and then deploy them to the cloud or the edge. To deploy the machine learning model, first we'll write a score script. And this is any arbitrarily complex business logic you would like to include. The key thing here is just to include an init function and a run function where you'll input your data, and then you can use built-in capabilities like model.predict in TensorFlow. In this case, we're going to deploy this machine learning model to a Kubernetes cluster that we've attached to our workspace using Azure Kubernetes Service. Using the combination of the scoring script above that I provided, as well as a YAML config file that specifies the dependencies, we'll automatically package the Docker container and store that in the Azure Container Registry using the model.deploy functionality here. Once we have deployed that Docker container, we can get a handle to the REST API URI that will enable us to pass in input values. And we can go ahead and test that model by writing a simple function that takes the input values and runs it through the REST API. Here we can see I've got a number of different sample Stack Overflow questions, and I'll simply iterate through them, put the results into a Pandas data frame, which we can then visualize here. Previously, I saw that the model looked like it performed pretty well based on the validation accuracy, and based on these input values, it looks like it got pretty darn good results with a really high probability, sometimes more than 99%. So I'm very confident in deploying this model and using it in my business processes. Now, to get the best quality results on a continued basis, we'll want to monitor and make sure that the model continues to perform well. And we'll use machine learning pipelines to continuously retrain this model as new input data comes into the system, because over time, we might change and add new services, or we might notice that people are asking questions in different ways. So we'll continuously train the model to keep it up to date. Machine learning pipelines allow using multiple different types of compute in the process. In this case, I'll use a CPU cluster to be able to prepare the data that's incoming and then train the machine learning model. Here we can see I've got a reference to the new incoming data. I'll specify the same hyperdrive config steps. I'll have a arbitrarily complex Python script to prepare the data, and then I will validate the results and register the model in this pipeline as well. I'll stitch together all of those different steps into a pipeline, and then I'll publish the pipeline. This exposes a REST API that I can invoke to run this pipeline over and over. So if I have some external agent that I want to call the pipeline to run it, I can do that. Or I can use the built-in scheduling functionality as well. When I run the machine learning pipeline, then I'll get a link here as well, so I can monitor how well that's performing. And we can see that the individual steps of this machine learning pipeline are doing well. Everything is completed, and the new version of the model is registered. So hopefully you can see that we've got a couple of different ways to easily train machine learning models and deploy them at scale to solve the natural language processing scenarios. Now, before we go on to show you how to use the automated machine learning to forecast volumes, I want to find out, do we have any questions from the audience yet?
Well, yes, Chris, there is a dedicated area for questions, so keep your questions coming our way. And a question for you, Chris, can anyone in the data science team create as much compute as they want? And how can we control our costs?
Yeah, that's a great question. So Azure Machine Learning offers capabilities for IT administrative type scenarios in addition to the data science experiences. You can use role-based access control to enable certain people to create the compute and control the sizes of like how big a cluster can get concurrently, so you can restrict your costs. And then they can use that functionality to grant permission to the data scientists to use the compute, but not necessarily edit the compute. So they can't create new clusters or make the clusters bigger than they're allowed to make them. And so that, in addition to the auto scaling, the auto shutdown, and the low priority, are all some of the key ways that you can manage your costs. So let's go ahead and go to the automated machine learning demo with Sabina.
Thanks, Chris. So let's quickly talk about the machine learning process. This process is known for being time-consuming and quite complex, and some of the steps you see here attribute to that. The first is data featurization. When we talk about data featurization, we're talking about steps like how you handle missing values in your data, or how you'd add additional contextual information to enrich your training data. Alongside this, we also have to consider algorithm selection and hyperparameter tuning, where the search space is extremely wide. There are many different algorithms and models that apply to a problem, and likewise many different hyperparameter combinations that will apply to that algorithm. So then how do we simplify this process? Well, what I'm actually going to propose is that we go ahead and leverage automated machine learning to automate the machine learning process. So let's take a quick look at how this works under the hood. It all starts with user inputs. You come in with your data as well as different configurations and constraints. An example of this could be how long you want to run for, let's say something like 3 hours. Once you've done this, you can be as hands-off as you'd like. Automated machine learning will automatically handle the data featurization. This includes handling those missing values like we talked about, but also adding other information to your data, such as holiday information and even weather. Once this is done and your data is ready, we go ahead and go into algorithm selection and hyperparameter tuning. Automated ML will actually intelligently test a variety of different models and hyperparameter combinations in parallel to return the best model for your data. Not only do we return the best model, but also all the other models that we attempted. Now that you have all of these models, odds are you're going to want to analyze one of them. So when we talk about analysis, we think of model explanations. The most popular model explainability that we offer is feature importance. This tells you what features in your data impacted your model's results the most. So in our example, where we're trying to predict the volume of Stack Overflow questions, the thing that might impact the model the most is actually the team itself. Perhaps that team has a really large dev community, or perhaps you know that holidays, you're bound to see a lot less volume. So these features actually give you additional insight. So we've talked about the machine learning process, how we could simplify with automated machine learning, and a little bit about explanations. Let's go ahead and jump into a demo to learn how this works live. So here I'm popping into the studio, and I'm actually in the automated ML authoring experience. Automated ML is one of the 3 authoring experiences alongside notebooks and the designer. So I'm going to go ahead and start a new automated ML run. And here I'm going to start with arguably the most important part of the machine learning process, and that's your data. I have 3 columns here. The first is a date, and this is daily information. The next is a tag, and the last is the volume. So what I can actually see here is that I have multiple teams such as DevOps and storage and have their daily volume per team. Now that we've quickly looked at the data and understood the problem, let's go ahead and get started. Here I'm going to configure the run. I have to choose an experiment to house my run. I can either select an existing one or create a new one. Here, I'll go ahead and create a new experiment. Next, I have to select my target column. This is purely what I'm trying to predict. In our case, the volume. Finally, I select the training cluster. Chris spoke about this lightly, but you can also go ahead and create a new training cluster here. Now we're going to click Next. Now it's time to focus on the task. So our task is time series forecasting. Here, we're going to let automated ML know which column represents our timestamps. In our case, that's date. Next, we have the optional group by columns. Think about this for a second. We actually condensed all of our information into one data set. So that means all the different information across teams is in one place. So we need to let automated ML know how to create many forecasts, a forecast per team, when it's only working with one file. So here we're letting it know that we want a forecast per team. Next, we're going to set the forecast horizon. This is essentially how far out into the future we want to predict or get forecasts for. Automated ML will auto-detect this for you, or you can go ahead and manually enter a value yourself. Now I'm going to go ahead and leave this as auto-detect. You can optionally enable deep learning, which will generate DNN models for you post-training. So I'm going to go ahead and kick off this run. Now, automated ML is starting on the preparation state. This includes pre-processing, those missing values we talked about. And while this gets started, I'm going to go back to the automated ML authoring tab and click on a pre-run experiment. Now this experiment is with the same data set, and here I can see a best model summary and other metrics. So I can see my best model, etc. On the Data Guardrails tab, I get a list of checks and balances. This can tell me more about how you handled those missing values in my data. And in this case, whether or not my frequency aligned to what Automated ML expected. If we pop over to the Models tab, we can see all of the different models that Automated ML generated. And we can go ahead and deploy, download, or explain our best model. So if I click on our best model, I can click deploy. Here we're going to have to name our deployment. So we can call this deployment. Then we choose the compute type. I'm going to choose Azure Container Instance. And that's all you have to provide. You can go ahead and deploy. We refer to this deployment as one-click deployment because everything is pre-packaged automatically for you. You don't have to worry about a scoring script or environment file. If I go over to the Details tab, I can actually see the status of all my different deployments. I can see I have 2 previous successful deployments and the one I just kicked off. So let's focus on this forecast deployment. Now that it has a REST API endpoint that I can hit to get predictions, I'm going to quickly pop over to Power BI and look at a data flow so that I can gather those predictions. Here in this data flow, I have date, team tag, and volume. Volume is optional. I only kept it here to kind of compare the results that the model brings back to my actuals for a little bit of analysis. These dates have to fall within the horizon that I set when I was configuring my run. So to call the model, I'm going to go up here on the top right and click on AI Insights. As you can see, Power BI has linked to my AML workspace, and I can see all of my different deployments here. And I can see that forecast deployment that we saw. Power BI also intelligently maps the columns from my data flow to what the model expects, date and team tag. So I'm going to go ahead and apply. So now Power BI is querying the model that we generated, that best model, and going to bring back the prediction results. And we see this in form of a new column in the data. If I go ahead and analyze some of this, we can see that the actual volume versus what the model predicted is actually pretty close, considering I didn't train this model for all that long. So now that we have a data flow in Power BI, we can also generate reports. Here I have a Stack Overflow time series report showing the different forecasts per team. It's a great place to show information that you've generated to business stakeholders. So we've done everything from seeing the complexities and time-consuming aspects of building a machine learning model, and also how to simplify that with automated machine learning. We've seen model explanation and more, and now finally how to present that to an audience that can understand it.
Thanks, Sabina. That was a great demo showing how to use automated machine learning to forecasting. Now, before we dive into the Q&A, I wanted to share some other helpful resources. We've got more on-demand content at the link below. You can use your Azure free trial to get started as well. And we even have learning and certification courses so you can get certified in how to use machine learning and AI in Azure. So check these all out. But Anita, do we have any questions from the audience?
Well, yes, we do. So we are now heading to the Q&A session. So the first question is, how do we know when we should try using automated ML versus regular Python code, such as using scikit-learn directly?
Yeah, that's actually a great question, and I'll take that one. So I really don't like to think of automated ML versus a more manual code perspective. I like to think of automated ML as a small part in that major workflow. So what are the pros of automated ML? You can automate the hyperparameter tuning, the algorithm selection. So instead, if you are a code persona, you can leverage automated machine learning to generate a really good baseline model, and then use Python scripts and other resources to further tune or evaluate that model. Now, if you're coming from a developer or analyst persona where perhaps building models is not your primary work, then automated machine learning now allows you and lights up the possibility for you to work alongside data scientists to build these models. So again, I just see automated ML as part of the bigger workflow.
Thank you, Sabina. So keep your questions coming. The next question is for you, Chris. Can we use TensorFlow with Azure?
Yeah, absolutely. As I showed in my demo earlier, you can use TensorFlow in Azure. One of the key tenets of Azure Machine Learning is that we're open and interoperable, meaning that you can use any machine learning framework inside Azure, including TensorFlow, PyTorch, and many, many more.
Great. Sabina, can you explain the difference between hyperparameter tuning with Hyperdrive and automated ML hyperparameter tuning? Like, what's the difference there?
Yeah. So again, when we look at the pros of automated machine learning, it's about automating some of these processes. So if you want some flexibility, you can still get that from automated machine learning. But if you want true flexibility to define your search space, how you're going to terminate early, what scores are important to you. So just for hyperparameters, then you would use something like Hyperdrive, where it's really hands-on. You can directly write the code needed to get the information you need, so that extra flexibility. Versus with automated machine learning, you're letting the system decide the best values and return that back to you. So they both have their major pros, and I suggest actually trying out both of them, but one is just a little more flexible.
Cool. What are the main reasons and benefits, like why I would want to train my ML models in Azure ML instead of my local machines, which can be pretty powerful too?
Yeah, I actually usually start with my local machine myself. Azure Machine Learning fully supports using your local laptop or desktop to train machine learning models using VS Code or Jupyter locally. And the Python SDK can connect to the cloud just to do things like logging the key metrics and keeping track of your log files, for example. And then once you've trained your machine learning model and validated your network architecture for DNNs, for example, then you might want to scale up on a larger data set. Then you can scale out to the cloud and use the more powerful GPUs or distributed CPU clusters as well. So that oftentimes more data beats better algorithms. So using the power of the cloud can be immensely helpful. Also, when you're working in the cloud, it makes it easier to collaborate with others. So using the built-in notebook experiences to both store, share, and discover what the rest of your team is working on can increase your productivity as well.
Really cool. Oh, I love this question. Can we get the code of the best model that we got from AutoML?
Yeah, that's a really great question. So there's two answers to this. The first is you can, of course, deploy or download any of the models that automated machine learning generated and continue to develop that model. However, we are actually in the process of building what we refer to as code gen, where we will generate the code after you finish training. So if you come through the UI like I showed in my demo, you can click a button easily and we will generate the code that would let you retrain or further work on this model.
Cool. So we do have a lot of questions coming about the demo content. Can we get access to that?
Yeah, it's available out on GitHub today, and hopefully one of the moderators can share the link to it. But if you search for Azure Machine Learning, GitHub, TensorFlow, then you'll find a bunch of samples, both that we walked through today as well as more.
Cool. A question for Sabina. You mentioned forecasting horizon. How long time horizon can automated ML predict forward?
That's a really great question. So while this does apply a little bit to your scenario, usually you want to predict only half of the amount of training data you have. So if you have about 4 years of training data, you'd only want to predict about 2 years. However, this depends on other variables that impact. So if you know weather is part of your data, you only want to predict as far out as you know the weather. I hope that provides some clarity.
Cool, that's really good. And does it support any scheduling to periodically update the model?
Yeah, using the machine learning pipelines, you can schedule the process to run to train, validate, and redeploy your model on a regular cadence based on time. Or the machine learning pipelines can even listen to changes to the underlying data, say in Azure Data Lake or Azure Blob. And so as you have new incoming data, then it can rerun that pipeline based on that change of the data. And so you, again, there's no point in scheduling the pipeline to run if the data hasn't changed. But if the data does change, run the pipeline, validate whether the new model is better than the old one, and automatically roll it out using an approach we call ML ops, which is the automation of the processes for machine learning.
And one last question, is it worth learning Python?
Yeah, in my opinion, it is. However, if you are a .NET developer, for example, there are other frameworks like ML.NET that enable you to get started with machine learning as well. Right now, the broadest support in the ecosystem for data science, the widest variety of built-in libraries and things that make it really easy to do data science, like data exploration, For example, Python is becoming, super popular. It's growing like crazy. So it definitely would encourage learning it as well.
That brings us to the end of the session. Back to you, Chris.
Great. Thank you all so much. It's been a pleasure to present to you, and I hope you enjoy the rest of Build.